reading this section because I always read the book before I present. I'm actually really excited about giving this really short talk on this, just because it brings in a bunch of different facets, from microbiology to chemistry to environmental health to stuff you can relate it to. So really excited about this. First, the book kind of puts these PowerPoints together, and then I go through and edit and add stuff to them to make it a little bit more interesting.
For whatever reason, it's focusing.
Oh.
Yeah, there you go.
Okay, cool. Okay. So the book puts together these PowerPoints, and I go through and kind of edit them as I see fit. But this is actually a really true statement. The dose makes the poison. You guys all know that too much of anything you can die from, and it can become poisonous, such as water or Tylenol. If you don't take the right amount of dose, or turkey, yes, the protein tryptophan will kick in and you will fall asleep. So the dose makes the poison. So when we look at health and environmental hazards, we have to look at what is the probability, what is the risk, and what is the possibility and probability of these happening. So risk, what is the probability of suffering harm from a hazard? One example I can think of is risk is all based on probability of something may happen. We can't always live in this fear of something may happen. Obviously, you want to stay clear of some bad neighborhoods or whatever, but pumping gas, there's a risk of you guys getting some gasoline on your skin and that getting on your clothes, and then that touching your other clothes when you wash them, trickle down effect. That is a real probability. A probability of one of our local dams breaking is very, very low. So take that into consideration. Probability versus possibility. Probability is that is the statistical analysis of if something is going to happen, and the reason I use that is we calculate, let's use water, storm events, 1 in 100 year, 1 in 500 year, 1 in 100,000 year. For probability, that's a statistical math calculation that you can do and actually name it to something. Like we've had 1 in 200 year storms here in the last 12 years, 15 years here. Whereas the possibility is more of, is it going to happen? Will it ever happen? I don't know. Is there a probability? Maybe really low, but is it possible? So that's the best explanation I can kind of distinguish between those two. What are some common risks in our own lives? And I was thinking about this last night. I was just like, everything you do has risk. So that's why I say we try to mitigate every risk. Filling up your gas tank, getting in the shower and not scalding yourself with hot water. That is a risk that most people face. And I'm sure most of us have done that. Or you turn off the water and it's cold, or that's risk too. Or you get into a car accident. Those are all risks you take every single day. It's how you assess them and how you manage those risks. Risks is how we face that in the environmental and personal field. So how do we assess the risks? We identify what's the hazard. Let's just say filling up your gas tank, because that has, most people drive cars here, or they have an electric car. I've had an electric car before. What's the hazard? Filling up your car. I mean, you have the fumes that you can inhale. You have the gas that can spill out. What's the probability of that? They're pretty safe nowadays. You don't see gas flying everywhere right anymore. I know at some older gas stations when I was younger, it would overflow the tank if they didn't have the right stopper on there. And what are the consequences? And then how do we manage those? So we assess it and then we manage the risk. So we compare that risk to other risks. What kind of car do I want to drive? As using the gas example, risk reduction. How much should it be reduced? Well, if you have to drive a lot, you're going to be filling up a lot. So that's you can't get around that. Reduction strategy. How will the risk be reduced? Maybe buy an electric car. You have to look at the risk and then assess and make a management scheme for that. And you can kind of do this with most things in your life, such as finances and everything, but this is strictly for a environmental standpoint. So many different types of hazards that we face. Biological, we have pathogens, which are viruses or bacteria that cause disease or infections. Chemical, gas stations. People don't know this, but home cleaning supplies are a huge chemical source of hazards in their home. Bleach is not fun. If you guys have ever cleaned, there's a reason they suggest that you wear thick metal gloves and you throw them away after. Or the thick, you've all seen the yellow cleaning gloves. Physical hazards that we encounter in the environmental field. When you guys start working at, and let's say you get a job at a big manufacturing plant, they'll have arms that are swinging that could take off an arm or take off your foot, or you have a backhoe that can hit you. That's physical hazard. What's a cultural hazard? I struggled with that last night. I was like, what is a cultural hazard? Right now, we in America live in a culture where we have OSHA, the Office of Safety and Health Assessment, OSHA, which is they protect us from a lot of things, from unsafe working conditions, where if you look at other countries such as China, India, all these developing second and third world countries, or first world countries, excuse me, they don't have these cultural conditions such as CHP that make you not go 100 miles an hour down the freeway, that keep you safe, right? So when we talk about cultural, that's a big thing. Unsafe highways. If I could, I'd go 100 miles an hour, but we live in a culture that's not safe. So, and lifestyle choices, smoking, drinking, all that fun stuff, eating. Like I said, anything can be a poison. Just look at the dose. So infectious diseases. What are biological hazards? Infectious diseases, pathogens invade the body and multiply. That's what a pathogen does, right? You guys start getting a little bit sick, and then you go into full-blown sick, right? And you got runny nose, all that fun stuff, until your body can eventually make antibodies for that and fight against it. Transmissible disease, contagious or communicable disease, meaning that if I'm sick right now, if I'm showing signs, even if I'm not showing signs, there's certain bacteria and viruses that there's an incubation time where if I intake a virus from, let's say, one of you guys or vice versa, it will stay in me and incubate for 3 to 5 days, and I'll still be contagious. I'll still be giving out the virus without any signs of that. And if you guys have probably experienced this when you're like, go to a family gathering or the mall and you're like, why did I get sick? Well, because no one in the family was sick, but they had incubation time where the infection was growing, just signs hadn't showed up yet. Infectious disease is transmitted between people. Examples: flu, autoimmune deficiency, AIDS, tuberculosis, and measles. Tuberculosis, believe it or not, before I started teaching here, I had to get a TB shot. So it's still a recurring thing that happens in first world countries. Non-transmissible diseases, I was looking at this, not caused by a living organism. These are more of your hereditary genetic disorders. So you're going to see, if your dad was, more prone to diabetes, or your mom, or if you don't know your mom and dad, I mean, those are what we call non-transmissible diseases. Your predisposition to certain types of cancers, diabetes, heart cancer. I don't know. We highlight diabetes, and I would like to get to a slide that actually shows what the death rate for diabetes is, but it's outrageous. So, infectious disease spread through where? Air. You're walking through the mall or through, a house at Thanksgiving. We're coming up. Waterborne illnesses are pretty low. We don't see much of them. You guys would definitely get a boil water alert, and it'd be all over the news if we had infectious diseases in the water. Food. I'm not qualified to say what type of QA/QC, quality assurance, quality checks that goes on with food, but I know there are, and then bodily fluids as well. Of course, sharing anything with someone else that's sick is obviously going to get you sick. So diseases can spread from one person to another. So what degree do we call, something like your family gets sick? And I know you guys have all heard a story. Well, my daughter got it, and then my husband got it, and then I got it. You guys have all heard that, right? Well, what happens when it gets bigger? So we look at epidemics, and people say, well, this is an epidemic. And I was thinking about what's the most common, for our time area, what's the most common epidemic that I can think of? I can think of Ebola. Remember we had that big Ebola scare, and everyone from Africa was coming in, and I think it was just Africa, West Africa, somewhere in Africa, and we kind of had the visa stopped, the visa stopped where you had to get tested and everything like that. That was an epidemic that, in a community at a particular region, it did spread a little bit to worldwide, but I don't know, I wouldn't really call that a pandemic. pandemics, when they talk about this, they usually mean that the death rate is a lot higher. So epidemic, you may have, all of Southern California or California experience something, but pandemics go from country to country. And the best example I have for that is the Black Plague that is estimated to kill 75 to 200 million people in the 1346 to 1500, and it came back after the 16th and 17th century. That was a pandemic, and if you don't know about the Black Plague, basically the rodents would carry around fleas, and the fleas would then bite you. You would get the plague, and that's what the issue was. So, and we have that now, even at Yosemite, which is killing people. And I can't think of it off the top of my head. People that sweep out the bunks that you stay at Yosemite National or State Park. Rats poop, and then the poop gets aerosoled, and you breathe it in, and then you get an infection. Google it, you'll find out. You'll find out what it is. But that is still something that's going on from rodents. So, infectious disease remains a threat. Okay, the one thing that we did want to talk about is disease-carrying bacteria have developed genetic immunity to widely used antibiotics. We're going to get into that as well as pesticides. Okay, so we have humans. We interact with pets, livestock, wild animals, insects, food, water, air, in between us, and if you're pregnant or you have a baby, your baby or your fetus. And, there's a lot of things that, these things touch that we don't see. Pets touch the water, these are all intertwined and they all touch us. Like I said, the best way to stop not communicable diseases or transmission of disease is washing your hands. So, or using the Purell. So deaths per year. I thought this was pretty interesting. Deaths per year, pneumonia and flu. I never knew why they pushed the flu vaccine so much, like getting your flu shot each year. I know right now you can just drive up and they'll just stick a needle in your arm and get you. Well, that's why, because usually it targets the young and the old, and 3.2 million people die each year of it, which is very, very big. It's a huge number for the world. Second would be HIV, AIDS, which is a virus, tuberculosis, which is you can treat, but there's a vaccine for it. Wait, let me retract that. No, it's not a virus. Yeah, it's the TB test. Yeah, I got a TB test to see that I'm not carrying TB. Excuse me, there is no vaccine for tuberculosis. Yeah. There's a new strain. There's a new strain. Yeah. Yeah. Yeah, I'll get to that in a second. What Neville had just said. Basically, there's a new strain of tuberculosis, which is drug-resistant TB. Diarrhea. A lot of people don't realize this, but diarrhea causes a lot in third world countries. That's why Pedialyte, Gatorade are big if you do have diarrhea, just to replenish those electrolytes, because you are basically just letting water out of your body. Hepatitis B, malaria, and the measles. So those are the big major diseases that cause major deaths per year. So we talked about antibiotics being more, the resistance for antibiotics is increasing. Bacteria have a very high productive rate, quickly become genetically resistant through natural selection. Typically the way, when I was taught in chemistry, most drugs that are designed to break the cell wall of a bacteria, so they'll target a single bacteria cell, and they will lyse the cell wall, exposing it, killing the bacteria cell, excuse me. That is the way you kill bacteria. Viruses, you guys all know the flu. You get the flu, you have the flu. You will go through the courses of the flu, and your body will then generate antibodies after it's figured out a way to replicate an RNA or a DNA sequence in the virus and make antigens, and and then the flu will then subside. Some viruses, though, our bodies cannot do that, and which is, we talk about HIV and AIDS. That's not something we have a cure for or a vaccine for. Humans travel and international trade spread bacteria. So, I mean, I don't know if you guys ever watched the movie Contagion. Have you guys seen the movie Contagion? No? If you watch that movie, it's a pretty good movie. It's out recently. It's basically about a pandemic that affects the entire world, and it's pretty interesting. And it kind of shows how touching one thing and then eating one thing can really affect the rest of the world if something's not clean. It kind of shows you at the very end about what happened. So it's actually a really interesting movie. Overuse of pesticides, overuse, and I put underuse of antibiotics. Overuse of antibiotics, yes. Doctors prescribe antibiotics too much for certain drugs and for certain illnesses that they do not know whether it's a virus or a bacteria. So if you have a virus, they will give you some amoxicillin, 5-day cycle. That's very a Z-Pack. Sorry, I used to be a pharmacy tech, so I kind of know this stuff. They don't know, so they'll just treat it with a broad spectrum antibiotic. Well, what happens if you don't take it, or if you're like, hey, I took it for 2 days and it's not helping me, but you're supposed to take it for 5 days? That just gave your symptoms, the bacteria, a chance to say, hey, this is what's killing us. Let's try to work around this and become immune or resistant to this type of bacteria. And there's certain types which we're going to get to here. So tuberculosis, kind of like we talked about earlier, kills 1.4 million people per year, strikes 8.8 million per year. Why is it on the rise? There's not enough screening, genetic resistance to antibiotics. Like I said, you over prescription, basically, hey, this is a broad treatment for what you're getting. So you're, I don't know if I've been sick and they've been giving me something. I'm like, you don't know if it's a virus or bacteria, so it's gonna help or not. Well, I'm gonna take it just because. Or they get it and they don't take all of it, which makes the bacteria a little bit more lenient against that. Increased person-to-person contact, and you will see this with most everything. People with HIV or AIDS are more susceptible to most everything. That's just a common comment. We put it in our consumer confidence reports at Mojave Water. If you have HIV or AIDS, a further water filtration system may be needed on your house, just because of the susceptibility. And like I said, that multi-resistant TB could create incurable diseases. There are some strains of, and we're all college students here, or we're all adults here, of gonorrhea that they're basically saying we cannot treat this anymore. And I know you guys have probably heard that. It's just so overly prescribed drugs that that bacteria is becoming very resistant. So multi-drug resistant TB, at least 2 of the most powerful line TB medications, and these are antibacterials. Isoniazid, I can never say it. Isoniazid, any fluorochlorine, quinolone, and I could say this last night. I couldn't say it today though. Rifampin. Sorry, excuse me. So any one of those, I mean, those are top shelf. You're gonna get if you get TB, you're gonna go to the hospital. If you guys ever seen MRSA, which we list right here, MRSA is Staph aureus that is methicillin resistant, which is a type of methicillin. Talk about penicillin. Those type of drug, that psyllin types of drugs, a family of drugs that is resistant to your Staph aureus that is naturally on your body. So not only are the bacteria starting to grow, immune to the antibiotics that are available. So that's not the only one. There's if you go to the World Health Organization, and what I did last night, there's 15 to 20 of their top key ones. And that's why I learned about gonorrhea and MRSA. Well, the MRSA I knew about, but there's also, penicillin isn't really prescribed that much anymore just because it was designed back in the 1940s. And drug chemistry and biological chemistry has come so far that drug just doesn't work on things anymore. So makes sense. Top viral killers, everyone gets the flu shots. HIV, which I know is very, we talk about now, is very prevalent throughout the entire world. and Hep V, which there are vaccines available. And my daughter's 1.5 years old, and I've never seen her get pricked with so many needles than when she goes and gets her vaccines done. That's amazing. It's like 20 vaccines. Emergent diseases, West Nile virus, and SARS. And we have 1 minute left. When did you want me to stop, Neville?
When you get to
Okay. Reduce your chances by infection of staying away from sick people. Wash your hands. Parasitic infections, malaria transmitted by mosquitoes. Lyme disease, ticks. You're gonna get a ring. That's a white ring with red on the outside. If you ever get Lyme disease, which is caused by ticks, you hear country songs checking for ticks. Scabies, something that skin-to-skin contact with a burrowing mite. That's never fun. AIDS, we talked about that. How it affects. You know what? We get on malaria. The one thing I did want to show you guys, though, that this is something that I think needs to be shown. This right here. So when we talk about annual deaths from the World Health Organization, and we talk about how many people die each year, I mean, throughout the entire world. Poverty, malnutrition, disease cycle, 11 million. So poverty and malnutrition, that's what I'm assuming that too. So, third world nations, I don't got to tell you which ones are. You guys can Google and find out. The second one is tobacco, and that's over half of what the poverty and malnutrition. Remember we talked about lifestyle? That's directly attributed to it. Pneumonia and flu, and I was very surprised to see automobile accidents at 1.2 million, more than malaria, more than hepatitis B. So I wonder if that number's on the rise with all the cell phones and everything. But also, we talked about diarrhea. That's a big thing because you get so dehydrated when you have diarrhea. So, and like I said, get your flu shots. 3.2 million people die. So that's from the World Health Organization. And I saw that and it kind of stuck with me because I'm like, wow, malnutrition is 11 million people. And like not that far behind, you're only 5 million people away from tobacco. And I know that there's a lot of, I've read stories on and listened to TED Talks about a lot of third world people like China, people who used to work in the factories would smoke 2 or 3 packs of cigarettes. And now they're switching over to that vaping, which I don't know much about, but they're switching over to that because it's a lot healthier form. There's like a huge industry for that now too. So, but still, you're still taking in nicotine and ethylene glycol, which is the stuff that makes it smoke. So it's not good for you, but it's still a better alternative. So, sorry I couldn't give the full talk today. Would have been a lot more. I have a bunch of cool stories, but wasn't able to get to them. So, does anybody have any questions? No?
Well, I'll work on this and send you something.